Question number 4 is about two different pirates who found a treasure chest, and we want to see which pirate ends up with the most money. The first pirate, Blackbeard, takes $25,000 right off the bat. Seamus, the other pirate, is going to take the rest of the money, $15,000, so it looks like Seamus kind of got hosed on this deal, but Seamus is going to invest his money. So he figures he got less money from this pirate treasure, but maybe in investing it, he'll end up having a good long-term choice. Just kind of depends. So the question is, which situation is better? Blackbeard taking more money, or Seamus taking less money but investing it in a bank account? So, a modern-day pirate, if you will. Because we have to understand his account, we should build an equation for his account so that way we can let our calculator do this stuff for us. So the first thing I want to do is just make sure that I make a note to myself. For Seamus, we need his initial value. His initial value is going to be that $15,000 that he took, times his multiplier, which we don't yet know, to the power of how many payments the bank is going to give him for his investment. So let's figure out these things just like we did in the previous question. If I think about Seamus's situation, he's going to have an 8% interest rate. That's his bank's promise. And it's going to be compounded or divided quarterly. So that means his bank is going to take his interest rate and divide it into 4 quarterly payments. 8% divided by 4 quarterly payments means his bank is going to kick him 2% per payment. So he's going to make 2% interest each time his bank gives him a payment. Now I'll do the same thing and I'll convert that to a multiplier. If you're doing this stuff in your head now, that's great. You don't have to write it all down. It's totally okay. But we're going to take 100% of our money plus our 2% thank you interest payment. That's 102%. And if I convert that to a decimal, move the decimal 1, 2 places to the left, that's 1.02. There's my multiplier. So notice every time we get a multiplier, it's the same thing. So Seamus's multiplier is 1.02. Now we need to know the exponent, how many payments Seamus is going to get. So it says we are leaving the treasure in the account for 5 years. And his bank is giving him quarterly payments. So 5 years times 4 quarterly payments would end up being 20 payments that Seamus is going to receive. Again, you can do that step in your head or you can type it all in the calculator. It's up to you. So speaking of calculator, I'm going to grab that so I can do this calculation. 15,000 times 1.02 to the power of 20 payments. $22,289.21. He definitely made a lot more money, but he didn't make as much as Blackbeard. So unfortunately, comparatively speaking, Seamus still fell a little bit short. And since this question is asking who will end up with the most valuable treasure, it appears that Blackbeard ends up having more money than Seamus, even after Seamus's investment. So unfortunately, Seamus's strategy did not pay out, and Blackbeard ended up with more money. So hopefully that idea makes sense, that you can use these to quickly kind of estimate how much of an investment you're going to get. And hopefully you can see why this would be useful in the long run. Because oftentimes when it comes to our money, we have to make choices. There's rarely one person at a bank or in our family just telling us what to do. We are given a bunch of options and we have to make the decision that's right for us. So instead of just saying, oh, well, whatever, just like give me whatever's easiest, it is helpful to understand how some of this stuff works. Because even if you just have a normal phone calculator, you could quickly stand in a bank or at a car dealership or anywhere where you'd have to deal with money, and you could quickly type in a small equation that gives you a very good sense of how many payments you're going to have to make, or how many payments, you're going to receive. You can quickly figure out what percentage the bank is going to give you, and you can figure out how much money you'll have if you know how long the bank is going to extend your terms. So just a quick calculation can give you a much better sense of what's going on than just guessing. Or better yet, it gives you a better sense of what's going on compared to just taking somebody's word for it. It's hard to assume that somebody is always going to be honest with you about what's in your best interest. So, taking that into account, you might want to start to think about some of this stuff so that you can think about your best interest, always first and foremost, and you can understand what goes into these decisions. In any case, hopefully now you have a sense of what this vocabulary about compounding means, how to build a compounding equation, and how to make sure we understand generally how those numbers play out in real life situations. In the next lesson, we'll start dealing with more realistic numbers and hopefully get an idea of how we can start to use some of this in, again, practical situations.